Hello, class. This will be a recorded lecture for section 1.3, which ends chapter 1. We're just going to do first 3 sections. And it deals with some ideas of designing experiments. And again, quite a few definitions with regards to this. So again, I will be using some of the PowerPoint presentations to illustrate these. So these are what we're going to talk about with regards to the objectives in this section. And the idea of randomization experiments, or randomizing experiments, and trying to do that is usually a really good thing, as we talked about in the first section. And so let's talk about a randomized experiment and an observational study. So with regards to this idea is that there's usually 3 levels to an experiment. First of all, experimental units. Like, what are you studying? These can be people, animals, plants, could be temperatures of components, like was what I was usually doing, or aspects with that. And then these experimental units are sometimes called subjects. So if you're experimenting with people, those would be the subjects. If you're experimenting with different components in my power systems, as a telecommunication engineer, those would be the subjects. And then the outcome or responses is what is measured on the experimental unit. And then treatments are the procedures that are applied to the experimental unit. So here's the example of what the book was doing. And so, for example, here the experimental units are the plot of land. And the treatments are these types of seeds that they're putting in the land. And the outcome would be the amount of growth that they get, depending on these aspects of the experiment. For example, if I was doing my testing on my product, the experiment would be the product itself, depending on what type of power system we were putting together. And the treatment would be the measurement of the temperature of the components. And the outcome would actually be, what is the temperature of the components? Are they getting too hot? Are they at a good temperature where we'd feel comfortable being able to ship it off as a reliable product? And so this idea of randomized experiment, and hopefully when you read some of these scenarios, it should be obvious if it's randomized or not. And what this says, this randomized experiment is a study of which an investigator assigns the treatments to experimental units randomly. And so here you can see that it even says in the second sentence, a simple random sample of 30 first graders and another simple random sample of another 30 first graders. So you could see that this would be treated as a randomized experiment. And then what we talk about as an observational study is one in which the assignment of the treatment group is not made by the investigator. So what we're doing in this example here, and I'm going to read the whole one, is that a study is performed to determine how smoking affects people in a health group. So you get a group of smokers and a group of non-smokers and observe them for a period of time, here several years. And scientists observe different outcomes between the two groups. And here, this is definitely observational because the assignment of the treatment, smoking or non-smoking, was not made by the investigators. And so that's the difference between those two. Again, in the grand scheme of things, not a super important aspect of it. But talking about randomization and the advantage of it, And so the idea in a perfect study, treatment groups will not differ from each other. And that's a really important aspect of it. And in practice, that's virtually impossible to construct groups like that, but randomization gives us the next best thing. So that's why this idea of trying to get to the randomization. For example, what they're doing now is trying to get groups to test vaccines for the COVID-19 or get groups to be able to test certain therapeutics that would help with regards to this COVID-19 disease. And the idea of getting getting large groups together, this idea of randomization. So you would want people that are young, people that are old, people that are middle age, men, women, etc. with regard to that. So that idea of randomization is quite important. And you can see, you could read this aspect of it here, where their scientists are reporting the result of a study of a new drug. And you could see that they were split into two groups. The scientists split these patients up into two groups. One was given the drug and one was given the placebo. Same thing that they do when they test the vaccine. And you could see that 62% of the group that got the medicine did better, and only 35% of the ones that got the placebo did better. So you can see that that's quite a bit of a difference. So you would say that this medicine actually had a positive effect with regards to treating this disease, which they're stating here as HIV. So with regards to doing these types of experiments, especially these drug experiments, which are at the forefront right now of our lives, this idea of doing what's called a double-blind experiment. So not only are the investigators the one collecting the data, and the subjects don't know which one got the real drug and which one got theoretically the placebo. And those are typically the best way to do these types of experiments, because there'll be nothing, what we call a bias. So the investigators, might be hoping that the drug works. And so that, there might be a little bias that they know which one got the drug and which one didn't. So it's really a good idea to do these double-blind experiments where neither the subject matter or the investigators know who got the drug and who got the placebo. Okay, well, let's talk about this idea of confounding. And this will be the last part of this section that we actually go over. So a lot of words on this one, so I can let you read some of this ideas with regards to this. And so here's an example of an observational study, which the book says is less reliable. And this is a group of smokers and non-smokers observed for several years. During that time, a higher percentage of smoking group experienced heart attack. And so what it says, one problem with this type of study is that the smoking group will differ from the non-smoking group more than just the smoking part of it. For example, smoking is more prevalent in men. So if you kind of looked at the difference between the two groups, there's probably more men in the smoking group than there would be in the non-smoking group. And if you look at some of the other statistics, men generally are a higher risk of heart attack than women. So that idea of, due to the fact that there are more men in the smoking group, that this experiment might not be super reliable with regard to that. And this idea of what I consider what might be the second order effects is something that the statistics world calls confounding. And an example here is the gender was confounding. As gender is related to smoking, men smoke more than women. And heart attack is also affected by gender, where men typically get more heart attacks than women. So for this reason, it's really impossible, or it's not as scientific to determine whether the difference in the heart attack rates due to this particular experiment because of confounding. And you'll see that there are quite a few examples that this could happen. And then for those of you that are going into the medical field, this is something that you really need to understand and make sure that when you take a look at these studies that this confounding doesn't come involved with this. So let's take a look at this last example. And so this one says, in an observational study, effects of blood pressure on health. A large group of people of all ages were given regular blood pressure checkups for 1 year. It was found that people with high blood pressures were more likely to develop cancer, and with people with lower blood pressures. Explain how this result might be confounding. So before I looked at the answer, I thought of this idea of the age of people. I've realized in my life as I get older, my blood pressure is creeping up a little bit, still pretty good, but it has creeped up a little bit. And so older people do tend to have higher blood pressure. And unfortunately, older people tend to get cancer more often than younger people too. So the confounding part of this observational experiment or study would be the age, is that the age would cause that this might not be the best and will give you the most scientific results because of the confounding part of the groups and their ages. So here's a quick summary of what we just talked about. Again, I will upload the presentation with the recorded lecture as well. You'll see that when you go and do the homework in section for chapter 1, there's only a few questions with regards to this. You'll see that when we start doing more number crunching with regards to this, you'll see that there'll be some more questions with regards to that. So I'm going to end this lecture, and then for those of you that listen to this, I hope this was helpful. And hopefully after you do this, next time we get together in our Zoom class, if you can give me some feedback.